Hi everybody, today is April 1st, 2020. This is video number 2 for Algebra 2. We're going to start on section 10-1 today. We're going to break 10-1 into 2 sections. Because this is a new style of learning for you and for me, we are taking our time. So the trig identities that are available in the Algebra 2 section on my webpage, I would try to get those printed out for next Monday. We'll start using them then. But today, we're going to focus on something that is in chapter 10, so it's kind of new and it's kind of review. So what we're going to do is we're going to follow angles around to the different quadrants in the unit circle. And we're going to find trig functions given some clues. I have one worked out, and then I have some that aren't worked out that I'm going to work out for you. So these are the steps that you're going to take, and I'll actually work one of these out in a minute. So the problem is going to look like this. They're going to give you a trig function. This time it's tangent of theta equals 1. Now I put a 1 underneath it. They're not going to look like that when we start them. It'll just say 1. Remember, tangent's opposite over adjacent. And from that information, they want us to find the sine of theta. They're also going to put us in a certain quadrant, and they can do that 2 different ways. They're going to tell you that your answer is in quadrant 3, or they're going to say that your answer is between 180 and 270. Between 180 degrees and 270 is the same thing. They can ask it either way though, so I put both ways there. So what I did is once I read what they wanted me to find, I went over to here and I made a little quadrant system. Now, they said the tangent is 1, and we know it's opposite over adjacent. So the opposite of theta is 1, and the adjacent is 1 also. But notice I put negatives on both of them, because look at what quadrant we're in. This side is back 1. This side of the triangle that we make is down 1. And I had to use the Pythagorean theorem to find radical 2. So I did 1 squared plus 1 squared is 2. Square root of 2 is radical 2. Once I write all 3 sides of the triangle that I make based on the given information, then I can answer the question they wanted. They said, find the sine of theta. Well, we know sine is opposite over hypotenuse. So I go to the triangle that I'm going to make for every one of these problems. And I look at the opposite, which is negative 1. And I look at the hypotenuse, which is radical 2. And I make a fraction out of them, negative 1 over radical 2. Remember that they're going to rationalize the denominator. That's not going to be the answer on Alex. They're going to multiply the bottom and top by radical 2, and you're going to get negative 1 radical 2 divided by positive 2. I didn't put that step in. They're all going to look like this problem. The setup's going to be the same. The next one I will show you how to do it. If you get to the point in these YouTube videos where you don't need more examples, of course, you can move on and not listen to them, or you can listen to all of them. So the first example was given to you. The second example, here's the information you're going to start with. Okay, now I'm going to work one of these problems out for you from scratch. So we're going to start with secant of theta equals negative 3. Secant of theta equals negative 3. And they're going to tell us we're in quadrant 2. That's going to matter. So what I do next is I draw this situation. Also, we need to know what they want us to find. They want us to find tangent theta for this problem. So I start by drawing my quadrant, and I'm going to make a triangle in quadrant 2 based on this information. Don't forget, if it's a whole number, to put a 1 underneath it. Secant goes with cosine. Cosine's adjacent over hypotenuse. So secant, remember, then would be hypotenuse over adjacent. So now, the triangle that you make in quadrant 2 is always going to be made with the x-axis. And this is going to be theta. No matter which quadrant you are, that is true. So I complete my triangle like this. And it's now the sign of this, the positive and negative matters. So I need to fill in the hypotenuse and adjacent. The hypotenuse is never negative. So that negative on the 3 doesn't actually belong there. I'll show you where it belongs. So there's my hypotenuse, it's 3. The adjacent in quadrant 2, this is backwards 1, so that's negative 1. And then to find your missing side, the opposite, use the Pythagorean theorem. It's going to be 9 minus 1, which is 8. It's going to be radical 8. I have all 3 sides of the triangle. Once you have all 3 sides of the triangle, you're set. So I'm going to take a little bit of that away. They asked me to find tangent. So I write tangent of theta equals, remember tangent is opposite over adjacent. So I look at the triangle that I made. I go opposite, which is radical 8, over adjacent, which is negative 1. And I'm done, except that's not going to be the answer on Alex. They're going to break the 8 down to 2 radical 2. And they're going to have an answer like this. It's going to be negative 2 radical 2. Negative 2 radical 2. If you forgot how to break the 8 down, the radical 8, it's this. Remember, 8 is 4 times 2. This is a perfect square, so it comes out of the house. The 2 stays in the house. That is why radical 8 broke down to 2 radical 2, just in case you've forgotten. Okay, the next example. This time I'm going to write it the other way. So the question is the same though. They're giving us cosecant of theta equals negative 2. Cosecant theta equals negative 2. I am putting a 1 under it. They're asking us to find the cosine of theta. So they want us to find the cosine of theta. They need to tell us what quadrant we're in. And they're going to tell us in this problem by using the other method. It says that theta, the angle, is between 180 degrees and 270. That's just another way to say quadrant 3. Because remember, when we draw our axis, here's 180, here's 270, we're between 180 and 270, we're in quadrant 3. Now, same step, I draw a triangle. I draw a triangle with the x-axis like this, and the angle is called theta. I'm dealing with cosecant this time. Cosecant's a partner of sine. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. So I take my numbers. Negative 2 is the hypotenuse, but remember this is never negative, so it's just positive 2. And then the opposite is the 1, and you can see it's going down, so that's negative 1. I use the Pythagorean theorem again. It's going to be 4, take away 1. This is going to be radical 3. The hardest part is building the triangle. Once I've filled in the information they gave me, I use a Pythagorean theorem to find the missing side, I can answer the question. They want cosine theta. Cosine theta is opposite over adjacent. So I look at my, it's adjacent over hypotenuse. So I look at my triangle, and I look at my adjacent, which is radical 3, over my hypotenuse, which is 2. And this time I don't have to do anything to the answer. There's not a radical on the bottom. I don't have to break the radical down. It's done. Now I have a last example. And again, since this is a YouTube video and you have complete control, if you don't need this example, just shut me off. But if you do, here's one last example for you to use. Again, we have to start with something. And for this problem, it's kind of different looking, but it's the same problem. They're going to tell us the sine of theta equals -2 radical 5 over 5. -2 radical 5 over 5. A little uglier looking, but we're going to do it the exact same way. And they're going to tell us the quadrant for this example. For this example, we are in quadrant 3. They're just going to say it. I'm just going to put a Q3 so I remember where I'm at. I am in quadrant 3. And what they want us to find this time is they want us to find tangent. We can do that if I can make the triangle. Tangent theta. There's the setup. I go to my next step, which is draw the coordinate system, fill in the triangle. I'm in quadrant 3. I make my triangle, put my theta in, and then fill in the sides. We got sine this time. Opposite over hypotenuse. So I look at the fraction. Opposite is -2 radical 5. Make sure that I'm putting the negative in the right place. This is a y value. Definitely it's negative. And the hypotenuse is 5. And remember, never negative. So I'm going to have to think a little bit to find the missing side this time. Still the Pythagorean theorem. I'm going to go 25 because of 5 squared. Then I got to square this. It's going to be 4, and then radical 5 times radical 5 is just 5. So when you square 2 radical 5, you just get 20. And you subtract them and you get 5. So this is radical 5. Now be careful though, because we're in quadrant 3, x and y are both negative. So yes, the y was -2 radical 5, but so is that. That is a place that you can get tripped up on. So now I have all my triangles correctly, all my sides correctly labeled. So I'm going to write the tangent of theta, which is what they asked for. The tangent of theta is opposite over adjacent. So I look at my triangle and I look at theta and I go opposite, which is -2 radical 5. -2 radical 5. And then my adjacent is negative radical 5. There's my opposite, there's my adjacent. I've got tangent. I've got some cleaning to do though. Those two negatives will go, and these 2 radical 5s will go also. They cancel, and the negatives cancel. And if you look at that, all that's left is a 2. And you are finished. Thank you very much.